Let us now go through the existence and uniqueness theorem. So, um, we understand now what is the insertion method, and we understand how we get the values of xt's if we are given the value of x naught. So that is what the existence theorem is all about. So it says that consider the difference equation xt, and xt is a function of time t and previous x's variables xt minus 1, where f is defined for all values of the variable. Now, if x naught is an arbitrary fixed number, so if I know x naught, then definitely I can find x1 also, I can find x2 also, and so on, right? So if x naught is an arbitrarily fixed number, then there exists a uniquely determined function xt such that is a solution of the equation this and has a given value for time period 0, because for time period 0 the value is x naught. So if I know x naught, then correspondingly I can find out the value of xt's also. Now this arises a very, very important conclusion, that as the value of x naught changes, corresponding the value of xt will also change, right? Because xt is defined for a given value of x naught, as x naught keeps changing. So remember when I said x1, I said x1 is a function of 1 comma x naught. So as this value of x naught will keep on changing, the value of x1 will also keep changing. So from there I can say, for each choice of x naught, there is a different corresponding unique solution. So in fact, there are infinitely many solutions. For any x naught, you have one x1. As x naught keeps varying, x1 also keeps varying. So there would be infinitely x1s for infinitely x naughts. But for any given x naught, if I fix the value of x naught to 4, then the value of x1 would also be fixed to a particular value. So then you would have a unique solution. So for any given x naught, correspondingly you will have a unique solution for it. But as you keep on changing x naughts, the value of x1 will also keep on changing and xt's will also keep on changing. Now, this is the question that we were discussing in the last video. What happens when t becomes very, very large? Suppose I ask you to find out x100 or x1000, then what would happen? This is something that we have to understand. How does change in parameter affect its solution? Right? So if I change the parameters, how does my xt's change? This is something also that I have to see. So, but one thing is clear for sure, that I cannot rely on the intersection method. Why? Because there are chances that I might incur computational error. So then what can we do is something very interesting. We are going to observe the pattern. So I'm going to find out x1, I would find out x2, x3, but then I would see what is the pattern that these are following, and then I am going to write down the value of xt. So let's see how that is done. So supposedly, I know that xt is a t minus 1 plus b. So, this is called first order equation. Just to give you a gist of what is first order equation, as I mentioned it in the previous video also, the first order equation is when xt just depends on one previous value of the same variable. So if xt depends on just xt minus 1, then that is a first order equation. If I would have written it like this, xt is a function of, say, two variables, ax t minus 2 plus bx t minus 1 plus c. If I would have written it like this, then it would have been a second order equation. right? Because it goes till 2 levels. Now, so I write down a first order equation, and then I say that x1 would be ax naught plus b1, x2 will be bx1 plus b2. Please correct this in the notes also. So this becomes x, instead of x1 I will write the previous value. So it will be ax naught plus b1. So this becomes a square x naught plus ab1 plus b2. So x2 gives you this value. Okay. Suppose I tell you to compute x3 for me. So you will say that ax3 is x3 is ax2 plus b3. So this becomes a, and instead of x2 you will place this a square x naught plus ax1 plus b2 plus b3. So once you solve it, you will get a cube x naught plus a square b1 plus a b2 plus. Observe the pattern that we have till now. You were given x1. x1 was a function of x naught. x2 was a function of x1, and so on. This is coming from what you're given. This is the difference equation that you're given. I substituted x1 here. I got the value of x1 in terms of x0. I got the value of x2 in terms of x1. But instead of x1, I did this insertion method. I put down this, and I got the entire thing again in terms of x0. I found out x3, and again I did the same method, and I found everything in terms of x0. So what is happening here is that x3 is coming as a function of x0. Similarly, I can do for x4, I can do for x5, and so on. But there is a pattern that I observe. What is the pattern? So as you go from x1 to x3, see that the number of a's are increasing. How? This was a x naught plus b1. This was a square x naught plus a b1 plus b2. This was a cube x naught plus a square b1 plus a b2 plus b3. So if I now ask you that you have to generalize this and write it for me, then you will say that once you observe the pattern, x3 is nothing but a summation of a. The maximum power is 3, and the power keeps increasing, decreasing. But as the power decreases, then the subscript of b is increasing, right? So a3 is multiplied actually by b to the power 0. In a way, there is no b. A square is multiplied by b1. A is multiplied by b2, and then there is b3. So if I tell you the other way around, b3 is actually multiplied by a to the power 0. B square is multiplied by a. b1 is multiplied by a square, and then there is an x0 factor. But these are only a's and b's coming here. So if I write down the pattern here, it is nothing but a to the power 3 minus power 3 minus k multiplied by b to the power k multiplied by b subscript k plus a cube x naught is x3. Suppose now I ask you that you have to write it generally for xt. So then k goes from 1 to t. A goes from t minus k to k plus a to the power t into x naught. This will become for xt, right? So just try and solve it for xt. So therefore, when k is between 1 to t, xt is this and this. There is an x naught because now I'm writing all these xt's only in terms of the base value. So there is this at x naught plus this is the factor that we just derived by seeing the patterns, right? Now, this is the difference equation solution that you have got. So the difference equation, which is xt is equal to at minus 1 plus bt, has this as its solution. This is an important question as far as the exams are concerned. Now, if I now ask you, so this is something that I've already told you, that, with the last factor that was coming, remember there was one term which just had b, that last b, there actually it was getting multiplied by a to the power 0, which is nothing but 1. So that last term was just b, right? Now, suppose that I now ask you that this is the solution that is given to you, and the second part of the question says that what happens if the value of b's are equal. So suppose I tell you that, all b1 is equal to b2 is equal to bk, and this is equal to a constant b. Then what is the solution of the difference equation? So pause for a second and try this question where, you keep the value of b same, and then you find out the pattern and find out the difference equation. So it is very simple. Instead of this bk, everything is just getting multiplied by the same b. So just try and solve that for once. So taking the special case where all bk's are equal to b, instead of bk I can simply write b, because b is getting multiplied with all the terms. This b can come out. So remember, it was a to the power 3 into b plus a to the power 2 into b. This was b1, b2, and so on. So it was so everything was multiplied by b's, right? Now all the b's are equal. So because the b's are equal, the b can come out. So this b goes out here, and I'm left up with this. But now understand, if this is summing up only a's, and the a's were coming like a to the power 3 plus a to the power 2 plus a to the power 0 and so on, isn't this a geometric progression, right? So I can just directly solve this. This is the GP, and the sum of GP is going to be this. So instead of this, I rewrite it like this. So, I resolved this part here, and for this much part, I am getting the answer as B into a minus 1 minus a to the power t upon 1 minus a. This is the solution. So for this part, for writing the final answer of xt is equal to a xt minus 1 plus b, my answer of the difference equation becomes this. Okay. So remember, this is the solution that I had got from solving the difference equation. Instead of all bk's, I wrote b. After solving it, I got this part. A b came out, and this thing became this. So this entire thing here became this. B into 1 minus a to the power t upon 1 minus a plus a to the power t into x naught. So here, if I solve that part, I'm going to get this. So final solution for the difference equation would be this. Let us now do a question for practice. So you're given that xt is equal to 1 by 2 xt minus 1 plus 3. Now this is a very easy question. Why? Because you know that the value of a is 1 by 2. You know that the value of b is 3. Because you know a and b, and we just now found out the general solution for the difference equation. Instead of a, you will substitute 1 by 2. Instead of b, you will substitute 3, and you'll get the final answer. Similarly, suppose I give you another question. So you know this becomes my final answer. Now suppose I ask you to solve this. This is a practice question. Please try it before the next class. You're given the value of a, you're given the value of b, and you have to solve it for the general difference equation. Thank you.